Imagine this. You are standing in the middle of an open field. It is 1 million years ago. You haven't eaten since yesterday. Your stomach is growling. Around you, the African savanna is on fire. Maybe lightning hit a nearby tree. The air smells like smoke. And something else, something good. You walk closer. There, lying in the ash, a small animal, dead, half burned.
You pick it up. It feels different from the raw meat you have eaten your entire life. Softer, easier to tear apart. You take one bite, and in that single moment, without knowing it, without planning it, you have just changed the entire direction of human history. This is not a story about food. This is the story of how cooking made us human.
For most of human history, our ancestors ate everything raw. Raw meat, raw roots, raw seeds. Tough, hard, difficult to chew. And here is something that most people never stop to think about. This took an enormous amount of time. Chimpanzees, our closest living relatives, spend up to 6 hours every single day just chewing their food. 6 hours! That is not a life. That is a full-time job of eating. Our ancient ancestors lived the same way. Their jaws were massive and powerful. Their teeth were large. Their digestive systems were long and complex, built to slowly break down raw, tough food over many hours.
And even after all that effort, the energy they got was limited. Because here is the problem with raw food. Your body can only pull out a certain amount of energy from it. Much of the nutrition stays locked inside. You eat, you chew for hours, and you still barely have enough fuel to get through the day. And a large, powerful brain, which is exactly what separates us from every other animal, needs a massive amount of fuel to run. So how did we get here? What changed everything?
In 2009, a Harvard biological anthropologist named Richard Wrangham published a book called Catching Fire: How Cooking Made Us Human. Wrangham had spent years studying great apes, and he noticed something deeply strange. Humans look physically wrong compared to every other primate. We have small jaws, tiny teeth, short digestive tracts, weak stomach acids. From a biological standpoint, we are built like animals that should already be eating soft, pre-processed food.
But why? His answer was shocking, and it has since become one of the most discussed ideas in human evolution. He argued that cooking food was not just a clever skill humans developed at some point. It was a biological revolution, one that physically reshaped the human body over hundreds of thousands of years, one that directly powered the growth of the human brain. He called it the cooking hypothesis.
Here is where things get genuinely fascinating. When you cook food, you are doing something your digestive system would otherwise have to do itself. You are breaking down the structure of the food before it ever enters your body. Proteins unfold, starches loosen and open up, tough fibers soften. This means your body can absorb more energy from the same amount of food, and it takes less effort to do it. A study published in the Journal of Human Evolution by Wrangham and researcher Rachel Carmody confirmed this. Cooked food provides significantly more usable calories than the same food eaten raw. The difference is not small. It is meaningful enough to change biology over time.
And this matters more than it might seem. The human brain is extremely expensive to run. It consumes roughly 20% of your entire body's energy, even when you are just sitting still, doing nothing. For comparison, a chimpanzee's brain uses only around 8 to 9% of its body's energy. Our brain size was only possible if we found a way to consistently absorb more energy from food. Cooking was that solution, and the human body responded. Over long stretches of time, as cooking became a regular part of early human life, our anatomy slowly changed. Jaws shrank, teeth became smaller, gut length shortened, and the energy that used to go into powering a massive, heavy digestive system it got redirected toward the brain.
This connection between gut size and brain size was formally laid out by researchers Leslie Aiello and Peter Wheeler in a 1995 paper in Current Anthropology called the expensive tissue hypothesis. Their conclusion? As the gut shrank, the brain grew. The two are directly linked. And the bones agree. Around 1.9 million years ago, a new species appeared in Africa, Homo erectus. Compared to earlier human ancestors, Homo erectus had a noticeably larger brain, a smaller and flatter face, smaller teeth, and a more slender body frame. These are exactly the physical changes you would expect in a species that had begun regularly cooking and eating softer food. As for fire, the oldest solid archaeological evidence of controlled fire use comes from Wonderwerk Cave in South Africa.
In 2012, a team of researchers led by Francesco Berna published findings in the Proceedings of the National Academy of Sciences showing evidence of burned bone and plant ash inside the cave dating back approximately 1 million years. Another site, Gesher Benat Yaakov in Israel, shows evidence of fire use around 790,000 years ago. By around 400,000 years ago, structured fire sites, called hearths, appear across multiple continents, from Europe to Asia to Africa. The exact moment humans first began regularly cooking is still debated among scientists. But what the physical evidence, the bones, the teeth, the brain sizes, the ash in the caves, tells us is clear. Cooking and human evolution are deeply, inseparably connected. But here is where the story gets even bigger. Cooking did not just change our bodies, it changed how we live together. When food needs to be cooked, people need to gather around a fire. They wait together, they share, and during that waiting, they talk, they bond, they make plans. Researchers believe that the shared meal around fire was one of the earliest forms of social structure in human history. Fire created a home base, a place to return to. It encouraged division of labor. Some people hunt, some gather roots, some tend the fire. It protected groups from predators at night.
A 2016 study published in Nature by Catherine Zink and Daniel Lieberman of Harvard found that even basic food processing, like slicing meat before eating, dramatically reduced the effort of chewing, freeing up time and energy for other activities. The campfire was not just a cooking tool. It was the first living room, the first meeting place, the beginning of us. Today, you turn on a stove without thinking twice about it. But every time you cook a meal, you are continuing a practice that is at least 1 million years old, and possibly much older. Cooking is not just a skill we learned.
It is the reason our brains are the size they are. It is the reason we are not spending 6 hours a day chewing raw food in a field. It is the reason we had enough time and energy to build language, culture, civilization, and everything you see around you right now. One ancient fire, one accidental bite of warm meat, one small moment in the African savannah, and the entire story of humanity changed forever. If this made you think differently about something as simple as cooking, the story of human evolution has thousands more moments like this, each one a small shift that added up to the species you are right now. If you want to keep exploring, subscribe. There is a lot more where this came from.